Let's look at finding the mean, median, mode, and mid-range of a set of data. How old was the typical signer of the Declaration of Independence? Was he a young man, a middle-aged man, or an elderly man? Here are the ages of the 56 signers of the Declaration of Independence. 40, 53, 46, 39, 38. These are the signers in alphabetical order. So what was the age of a typical signer? Well, given a set of data, there are different ways we can find a typical value in that set of data. We could find the mean, which is also known as the average. To find the mean, we add up the values and divide by the number of values. 40 plus 53 plus 46 plus 39 plus 38 plus 35 plus 50 plus 37, blah, 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 blah. And then divide by 56, the number of values. Add all those values up, divide by 56. We get 2493 divided by 56, which works out to be about 44 and a half years old, 44.52 years old. More generally, to find the mean of a set of values, x1, x2, x3, x sub n, we add up the values and divide by the number of values. So the mean would be x1 plus x2 plus x3 plus plus x sub n, all over n, the number of values. What symbol do we use to represent the mean? It depends on whether we're referring to a population mean or a sample mean. Now, a population includes everyone. A sample includes just some, not everyone. The data set includes every signer of the Declaration of Independence. So we have a population, not just a sample. We use the symbol for population mean, which is the Greek letter mu, spelled mu, but pronounced mu. So mu, the population mean, is about 44.52, around 44.5. On the other hand, suppose, for example, we wanted to know the mean height of adult males in the U.S. We can't measure all of them, so we'd measure a large sample of them. The data set does not include every adult American male, just a sample of them, so we have a sample, not a population. And we would use the symbol for the sample mean, which is x bar. So in other words, if we wanted to know the average height of the American male, we would probably never know mu, the population mean. We just can't measure 150 million guys. But we would know x bar. We'd know the mean of a sample. Okay, the CDC, Centers for Disease Control and Prevention, measured 5,647 males in the U.S. aged 20 and over and found their mean height to be, care to guess what the mean height of an American male is? It's 69.3 inches. So in this case, we'd say the sample mean is x bar is 69.3 inches. But since the sample's so large, 5,647 men, we're confident that the population mean mu is very close to the sample mean x bar, so we may as well say that mu is 69.3. Now, really, we can't be certain that mu is 69.3. We can be certain that x bar is 69.3, but because the sample's so large, mu is probably pretty close to 69.3. Given a set of data, there are other ways we can find a typical value in that set of data. We saw the mean. Now, let's talk about the median. We could find the median. To find the median, we put the values in order and find the middle value. The median is the middle value. The values are 40, 53, 46, 39, blah, 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 blah. But these values are not in order. In order, the values are 26, 26, 30, 30, 32, 33, 33, 33, 34, 34, etc. Note the range of ages, 26 to 70. Now, the youngest signers were 26 years old. Thomas Lynch Jr. and Edward Rutledge both were lawyers from South Carolina. And the oldest signer was 70 years old, Benjamin Franklin, a printer, author, politician, diplomat, inventor, and scientist from Pennsylvania, perhaps the greatest American ever. What a Renaissance man. Okay, to find the median, we put the values in order and find the middle value. So here are the values in order. They range from 26 to 70. Now again, when you find the median, you put the values in order and find the middle value, which is great if you have 5 values. If you have 5 values, there is a middle value. But there are 56 signers of the Declaration of Independence. If you have an even number of values, there is no middle value. Look at this. Let's say, for example, you had 4 values. There's no middle value. What would you do? How would you define the median, the middle value? Well, you take the mean of the middle 2 values. That is your median. And so that's what we do in this circumstance. In order, here are the values ranging from 26 to 70. The first 28 values are in red. The next 28, the second 28 values, are in green. So the middle two values are 44 and 45. 44 is the 28th value, 45 is the 29th value. And so the median is 44 plus 45 divided by 2, which is 44 and a half. That is almost exactly the same as the mean, which was 44.52, interestingly enough. Okay, in general, the median is a better measure of the typical value in a set of data than the mean because it is less sensitive to outliers. Outliers are extreme values. Suppose I have a class. Here's an example of what I mean by this. Suppose I have a class with 3 students, and these are the annual incomes of the families of the 3 students in my class: $30,000, $80,000, and $40,000. Find the mean and the median. Okay, the mean is the sum of these incomes divided by 3. So we end up with $50,000. The median of $30,000, $80,000, and $40,000 is, well, we need to put them in order first. $30,000, $40,000, $80,000, and when you find the median, it's the middle value. In other words, it's $40,000. Now suppose that one of Bill Gates' children, either Jennifer or Rory or Phoebe, here he is with his wife Melinda and their 3 kids, suppose that one of his kids joins my class. Calculate the new mean and median. New mean and median family income in my class. Okay, the class is 4 students, and these are the annual incomes of the families of the 4 students in my class. We have the $30,000 income, the $80,000 income, and the $40,000 income from before. Care to guess what Bill Gates' annual income is? $9 billion. That's basically how much his net wealth increased last year. $9 billion. So here's the mean. 30,000 plus 80,000 plus 40,000 plus 9 billion divided by 4. You end up with $2,250,037,500,000. It appears that the typical family in the class is quite wealthy, but in a sense, it's deceptive because the average family, the typical family in my class is really not wealthy. There is one wealthy family in the class, and oh my goodness, do they throw it off. They really have a way of influencing the mean, of boosting the mean. Okay, now the median of 30,000, 40,000, 80,000, and 9 billion is, well, again, since we have 4 values, an even number of values, the median is going to be the average of the middle 2 values, which in this case is $60,000. When we included a $9 billion annual income, the mean went from 50,000 to 2,250,037,500. So notice how the mean ballooned when you included that extreme value. The median, however, that just went from 40,000 to 60,000. So the median is less influenced by outliers and is thus a better measure of the typical value. Again, that's one reason why I personally and many others prefer the median as a measure of a typical value, because it's less sensitive to outliers. It's less prone to this ballooning or this shrinking due to an extreme value, an outlier. That's why I prefer the median. Okay, given a set of data, there are other ways we can find a typical value in that data. We could find the mode. The mode is the most common value. In order, the ages of the signers of the Declaration of Independence are 26, 26, 30, 30, 32, blah, 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 blah. Okay, and the mode is, can you see it? Can you see what the most common value is? It's 45. Well, actually, the modes are 45, 46, and 50. So 45, 46, and 50, because each of these occurs 4 times. So in this case, this set of data does not have one mode. Instead, it has 4 modes. Okay, given a set of data, there are other ways we can find a typical value in that set of data. We could find the mid-range. Now, the mid-range is the mean of the minimum and the maximum. In order, the ages of the signers of the Declaration of Independence are 26, 26, blah, 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 all the way up to 70. Now, the minimum is 26, and the maximum is 70. Thus, the mid-range is 26 plus 70 over 2, which, in other words, is 48.